In many problems, we'll come across common supports. And I want to go through a few of these common supports that you'll encounter in your problem-solving activities. Okay, so the first off, the spring, right? Sometimes drawn like squiggly in a straight line. Don't get that confused with the resistor for any electrical people out there. This is a spring. And we have this relationship of a spring, right? F equals Ks. All right, so this linear relationship where F is the amount of force that's in a spring, K is the spring constant. Spring constant. And S is the stretch or the displacement of the spring. So the displacement. So on this spring here, the farther that we stretch it, the more force it's going to have, all right? And the spring constant is kind of like the stiffness of the spring, right? So it can be a very stiff spring and we only pull it just a short distance and it still has a lot of force. Or it could be a very flimsy spring and we could pull it a long ways and still doesn't have a whole lot of force to it. Okay. All right, so this is the spring, and S, sometimes in some textbooks, S is written as X, all right? So we're gonna use S in this course, all right? S is equal to L minus L naught, or LO here, if you wanna call it that. All right, so what is this? L is the length of spring. And L naught is the unstretched length. So we want to make sure in this equation we're not putting in there the total length of spring for S. It's just the amount that it stretches, and this is the equation for that. Okay, so that's the spring. All right. And we will also encounter cables or ropes or things of that nature. So in the problems in the book, we'll assume that cables and ropes have negligible weight, meaning that in the whole system of things, the weight of the rope or the cable is so small that it can just be neglected. All right. And in cables, I'm going to draw a pulley here. If we have a cable wrapped around a frictionless pulley, right, the forces in the cable are directed straight in line with the direction of the cable, okay? And that gets me to pulleys. Similar to cables, unless otherwise stated in problems, pulleys have negligible weight. And then they also will have negligible friction most of the time, unless specifically stated in problems. And then the last one is a smooth contact. Contact. All right. So let's, for example, if a tire or a ball, it doesn't make any difference, is resting on this inclined plane. We have the weight of the disc. I'm going to say the weight of the disc downward. If it's resting on a inclined plane and it's a smooth contact, all right, the support or normal reaction there is going to be perpendicular to the surface that it's resting on. So this force is perpendicular to the incline that it's resting on. All right, so those are the common support elements.